Solving formulas. Solving formulas is very similar to solving for equations. The only difference is mostly everything is usually in variables. So you still want to isolate the variable you want to solve for by using opposite math. Combine like terms if possible, distribute if possible. If the variable you want to solve for is in the denominator, multiply both sides by the denominator. Usually you do this step even if you have a fraction too. If the variable you want to solve for is under a radical, isolate the radical and square both sides. That will clear the radical. If the variable is squared, isolate the variable and take the square root of both sides. So let's start with this. ax plus by equals c. Solve it for x. Here is x over here. On the same side is this positive by. So to move this to the other side, it's added, so you subtract. Subtract by from both sides. So you bring down the ax. These cancel out on the left. Equals c minus by. Next thing you want to do, a is multiplied by x. You got to divide both sides by a. So ax over a equals c minus by over a. This is a long division over the whole thing. The a's cancel. You're left with a equals c minus by, everything divided by a. Let's try this one. A equals 1/2 b times h. We want to solve it for b. When you have a fraction out in the front, you usually want to take the reciprocal and multiply by both sides. So the reciprocal of 1/2 is 2, so I multiply by 2. So 2a equals 2 times a half bh. The 2a equals, now 2 times a half, the reason this works is because it makes a 1. 1 times bh. Now I want to solve it for b, so I got to get rid of the h. This is multiply, so I divide. Divide by h, both sides. The h's will cancel here, so you're left with b. 2a over h is the answer. b equals n, capital T, capital W, divided by 12. Solve it for n. The first thing I want to do, again, I want to get rid of this 12, so this is divide by 12, so I multiply by 12. So multiply both sides by 12. I get 12b equals 12 parentheses ntw over 12. 12's cancel on the left. So I get 12b equals ntw. Now divide both sides by tw, because this is all multiply, so do it at once. Divide by tw, divide by tw. The tw's cancel, and you're left with n equals 12b over tw. F equals mv squared divided by r. Solve it for r. So now I have the variable in the denominator. I still, just like that 12 was, I still want to multiply both sides by r, because that will move it over here and I'll get rid of the fraction. So you multiply by f times r equals r parentheses mv squared over r. So by multiplying by r, the r's cancel on the right. So you have fr equals mv squared. Now I'm solving for r. Don't lose track of what you're solving for. This is a multiply by f. So I divide both sides by f, here and here. The f's cancel, and you're left with r equals mv squared over f. Let's look at this same problem again, and this time I want to solve it for v. And notice v is squared, so the last step I'm going to have to do is take the square root of both sides, but first I have to isolate the v squared. This problem starts out the exact same way. Multiply both sides by r. So I get f times r equals mv squared. Again, you can look at this step. It's the same step. I'm solving for v squared, so I got to divide by m. This is multiply, so I divide. Divide by m. Moves it over here. They cancel here, so you get fr divided by m equals v squared. Now I have to take the square root of both sides. Square root of v squared. Square root of fr over m. When you take the square root of something squared, it just pops out. So it's v equals the square root of fr over m. k1 over k2 equals m1 plus m2 over m1. Solve this for m2. Because this is set up like a proportion, I'm just going to cross multiply. So when you cross multiply, you're going to cross multiply each diagonal, and there's an equal sign in the middle. So when I cross multiply the K1 with the M1, it becomes K1 times N1 equals, now I do the other diagonal, K2 parentheses, M1 plus M2. So I need parentheses on this because there's two quantities here. Distribute next. So I get K1 M1 equals K2 times N1 plus K2 times M2. So the K2 goes over both parenthesis terms. Subtract K2 M1. Again, I'm trying to solve for M2, so I've got to try to keep this by itself, so I want to move this out of here. So I subtract K2 M1. Again, these are not the same terms, even though they both have an M1 in them. But because of these different K's, you just can't add them up. So what you're going to do is just leave them separate. So this becomes minus K2 M1 plus K1 M1. So again, just combining these and writing them out equals K2 M2. That's all that's left here. Finally, since I'm solving for M2, I can divide everything by K2. So divide this, the right side by K2, divide the left side by K2. K2's cancel. You're left with M2 on the right, and then all of this, K2 M1, a negative, plus K1 M1 over K2. Even though it looks like you could cross out these K2s, you cannot cross them out. It's only possible if the K2 was in all the terms on the left, meaning I'd have to have a K2 in this term as well, and then I could cross them all out.